All right, so first thing I want you to notice here is you've got all of those constants written up there at the top. You've got this equation written up here at the top, and notice here I just wrote use the energy constant and then use the change in temperature if there is a change in temperature, okay? I also put on each one of these a little heating curve so you can start to think about what section of the energy curve, of the heating curve, which section are we talking about here? Okay, so just read the problem here. And the first thing you need to do is just figure out what section of the curve are we talking about?
The water section.
The water section. Because it starts at 75, which is like right there in between 0 and 50, or in between 50 and 100, right? And it cools down to 20, which is like there somewhere, right? So we're talking about this part right here. So now, which of the constants is talking about water cooling down? By the way, just a little heads up, the letters that are on this like thing here are different than the letters that are on the one that's on your practice quiz. So just don't get thrown off by that. They're a little different. Which of these four is talking about water changing temperatures? Heat of fusion is talking about melting or freezing. Heat capacity of liquid water. That's the one we're talking about. So write it on there for yourself. 2.1 joules for every gram for every degree Celsius. Okay? So here we go. Q equals MC delta T. So Q is what we're trying to find because it says how much energy does it release to the surroundings. What's the mass? 140 grams. Which C are we going to use here? Which constant? 2.1. By the way, if you put the units of measure in this one, it's kind of cool because all the right units will cancel out. 2.1 joules for every gram degrees Celsius. Notice how I just stuck them down there on the bottom. I don't know why I always write my time signs with X's, but it doesn't really matter. Okay? And then what about the temperature change? How much does the temperature change? 75 minus 20, right? Which is 55 degrees. Right? So there you can see it. Grams cancels out with grams. Celsius cancels out with Celsius. And what are you left with?
Joules.
Joules, which is what you want to know, right? Because you want to know how much energy. So do the math there. I don't know what it is off the top of my head.
2.1 times 55.
Well, it's 140. You got to get all the numbers. It's a lot of numbers, isn't it? 140 times 2.1 times 55. 16,000 what?
170.
And by the way, yes, these are always really big numbers. Joule numbers are always really big. Actually, a lot of times scientists will talk about kilojoules instead of joules just because it makes the numbers smaller. We won't mess with it. Joules are good enough for us. So there you go. Try number 2. Yes. I'm going to solve number 2 quietly. So if you get stuck, you can look up.
does condensing mean here?
Condensing?
Yeah.
Condensing means like going from gas to a liquid. Like the condensation on the outside of your glass on a hot day.
So is that like sweating?
Well, sweating is, look, it's opposite of evaporation. Guys, I'm sorry. I forgot that I put kilojoules on this thing.
Is that in this problem?
It's not going to end up mattering. Just do it in kilojoules. But you can't do it in pounds. You got to change it to kilojoules.
Yeah, I'm completely lost on this.
Okay, so the only thing that's goofy about this one is that you have to change pounds into kilograms, but it tells you how to do that right here. So all I did here was just multiply times the conversion factor for that, and it get the answer. Okay, that's the only thing that's weird here. The only other thing that's pretending to be weird is that it's talking about kilograms and kilojoules. But if it's 2260 joules for 1 gram, then it must also be 2260 kilojoules for a kilogram. Same thing. So it doesn't change anything at all. You just keep doing it. Don't worry, on your practice quiz, I only did joules and I only did grams.
We practice was that.
Mm-hmm. Yep. Okay. For number 3, the same thing is going to be kind of a little bit true, is that we have kilojoules here. Well, 1 kilojoule equals 1,000 joules. So if you got 65 kilojoules, then how many joules is that going to be? 65,000. So to set that up and do the math problem, this is good final exam review material right here, okay? 65 kilojoules times 1 kilojoule for every 1,000 joules equals 65,000. Oops, 65. There you go. Now you have the number that you need. Again, I'm going to do this quietly. Does it help you guys when I do it quietly like that and like point at things? But it allows you to keep working if you think you know what you're doing.
Good morning, excuse the interruption, students and staff. At this time, it's 9:15. We need to have teachers dismiss the students for the Southwestern Michigan College campus field trip to door C. You should have a list of those students that are doing it. And to not clog up door C, if we can wait about 5 minutes without another interruption. At 9:20, we need the early college freshmen that are going on the 9th grade field trip. They also need to be excused at 9:20 to door C. So students, make sure you're going to the right school bus for your correct field trip. Keep an eye out for your teacher and have a good day. Thank you.
You guys see what I'm doing here? Just doing a little bit of algebra. I'm just solving for delta t. It's algebra 1. Does that make sense? It only looks just a little bit funny and confusing because there's units of measure in there. But just ignore the units of measure here and here and here. This is the variable that you're solving for. The 65,000 is from here, right? Because we did that. The 450 is from there. Oops, I'm sorry. I'm off the edge of the page there. 65,000 is from here. This one, I just did 450 times this. I just did the multiplication. When
talk to us about it?
Huh?
Can you go through them before, talk to us about it?
Sure.
Tell us what
Let me finish it because I have one more step and then it's just done. And I'll talk through the whole thing. So I'm just going to do 65,000 divide by. So there's the final. Okay, so I've got my equation here. Q equals MC delta T. Okay. Q is how much energy. Well, they told me how much energy, so I put the how much energy right there. They told me the mass, so I put the mass right there. They told me the constant because they told me it's liquid water at 20 degrees. The only thing that water can be at 20 degrees, right? So I knew that it was water increasing in temperature. So I found the 4.18 just by looking at which one of these is about liquid water. There's that. And then it says, what is the final temperature? So that means I'm trying to figure out what is the final temperature. So the delta T is the thing I'm solving for. So all I'm going to do here is just do this math problem. It's just an algebra problem. So I'm going to start by doing 450 times 4.18, and that's what I got right there, the 1881. Okay. I also just canceled out the grams because they were there and they're easy to cancel out, so I canceled them out. Okay. And then the next thing that you do is you just do, this is like the same math as 65,000 equals 1881 times delta T. So all I have to do is just take the 65,000, divide this whole thing by 1881. I don't know how your math teachers write this, but you're dividing the whole equation by that. Well, if you had 4 equals 2x, how would you solve that?
You would divide by 2.
Divide by 2, divide by 2, right? That's what I'm doing here. You divide the whole thing by 1881, and then that's what you got there. So this means that delta T, the temperature changed by 35 degrees, but it started out as 20. So if it changed by 35 degrees, that means now it's 55 degrees. That's tricky, isn't it?
Yeah, really tricky.
That's pretty tricky. If I remember correctly, this last one is a lot simpler. Are you ready for it? Number 3 is probably the trickiest we'll see.
More tricky than the test.
Like maybe more tricky than the test.
Will you have like a bonus question like that on the test?
Maybe. It probably wouldn't be exactly like that, but I might put something on there. A tricky one. Tricky in some way. It's all thinking though. If you think through it, you figure it all out. All right. Try number 4. Figure out what you can figure out. I bet you can at least figure out where on the chart we are here. Okay? Figure out where on the chart you are and get your equation going as a starting point. I'm going to do the first bit quietly here. Yeah. From the notes. It's just the same equation, only without the delta T part and using the heat of fusion instead.
Oh, so you can just write like H instead of like HF.
Yeah. Well, I mean, you can write the HF if you want to, but we kind of just use this equation because HF and HV, they both work the same way. If you want to write HF, you totally can do that. That's fine. That's it.